So, hey, quick review from Friday. Remember you had our different fundamental trig identities. We went through, we talked about all those. We kind of drew out some pictures to help describe them. Talked about how the Pythagorean identities come about there. Then I asked you to finish page 275 of your student journal, the extra practice. Let me get those answers up there. I believe we did number 1 as a class and number 3. Or at least started number 3. But number 2, check them out. Sine theta is negative 3/5. Tan theta is 3/4. Cosecant negative 5/3. Secant negative 5/4. And cotangent 4/3. Okay, so you have that 3, 4, 5 triangle that you can form based upon the information they give you there. Use the Pythagorean theorem to find that, or just use the Pythagorean triples. And then it's just setting up your ratios. Number 3, do the same thing. It's just this time you're in quadrant 1. You have C is root 65. And so when you put all that together, you get sine is 7 root 65 over 65. I did not show how to rationalize it there. I just assume we can do that. Cosine 4 root 65 over 65. Tan 7/4, secant 65 or root 65 over 4, and cosecant root 65 over 7. And then number 4, you're in quadrant 4 now, based upon what they give you here. Your sine is negative 2 root 3 over, or 2 root 13 over 13. Make sure it's negative because sine is negative in that quadrant. Cosine is 3 root 13 over 13. Tan is negative 2/3. Once again, tangent would be negative in that quadrant. Cosecant is negative root 13 over 2. It's the reciprocal of sine. And cotangent negative 3/2, reciprocal of tangent. Yes? It doesn't matter where you put the negative sign, correct. Just as long as it's negative. Yeah. Yeah. Okay, there's the answers for 3. Are there any questions on those 4 problems? Okay, really very similar to what we were doing on the warm-up today. Okay. All right, number 5, I believe we did as a class negative sine theta. Number 6, we also, I believe, did as a class sine cubed theta. Okay. Number 7, we did as a class, which was, didn't we do that as a class? Yeah. Okay, number 7 was negative 2 cosecant of x. Number 8, we did not do as a class. However, I'd like to do that one as a class. Okay, I know that you should have an answer. Go ahead and tell your neighbor what you got.
I looked at 9.6, not 9.7.
Okay. Let's try this. So this right here, if I just ignore the negative 1 for a minute, just think of this piece. What is sine pi over 2 minus theta? That is cosine. Okay. And then we'll put the negative sign back on. Negative symbol there. Secant of negative theta. Well, secant is the reciprocal of reciprocal of cosine, so that's 1 over cos of negative theta, which is the same thing as this piece right here just becomes cos theta. Okay. And then sine squared we could write as, actually, hold on, let's wait on that for a minute. Let's deal with this big fraction, okay? So we'll just kind of take this chunk right here and rewrite what we have. Okay? We have negative cos theta over 1 over cos theta. Good? Okay. Well, what is 1 over cos theta? It's the same thing as taking what you have in your numerator and multiplying it by the reciprocal of this, which is
cos theta. Right? For those of you who are like, what? I don't get what he just did there. To break it down there, that's that. We're dividing it by 1 over cos theta. It's divided by 1 over cos. Which is the same thing as multiplying by the reciprocal of that. Okay?
So negative cos squared theta.
Negative cos squared theta. So really what we have here is negative cos squared theta. We get that from this junk. Oops, sorry. Zoom out there so you can see it. So from this junk, this mess, we have negative cos squared theta. And then we have this. Minus sine squared theta. Okay? Well, that's a cos squared and a sine squared. If we were adding them, that'd be nice. Right? We could take out a negative 1. So factor out a negative 1 there, and we're left with cos squared theta plus sine squared theta. That's kind of good. Because cos squared theta plus sine squared theta is 1. So I now have 1 times negative 1, which is negative 1 is my answer. All that junk equals negative 1. We love math. Yes, I agree. Hey, by the way, guys, there's multiple ways to get there. I actually, on my paper, my answer key here, I have it done a complete different way. I have that. So I've done it 2 different ways. Okay? All right. Hey, questions there?
What's next?
All right. Those 3 with their earbuds in, make sure you take them out right now. I know you're getting important information from the government, but probably need to take them out. The government will wait. Okay? All right. Okay. Last piece. And then I want to get you guys working on today's stuff and practicing this. Verify the identity. All right. When it says verify the identity, make sure you understand that it's saying make this side equal that side. That's how you verify it. Usually it's making the mess look like the non-mess. Now that's not always the case because on number 10 they both look like messes kind of. Okay? But I would more like to think of it as make the left look like the right. Okay? If we kind of follow those guidelines in here, at least we'll all be on the same track. So make the left-hand side look like the right-hand side. Okay, so make notes to yourself here. Make the left side look like the right. That's how we verify it. You guys gotta tell me when I'm off the screen, man. Thanks. Sheesh. It's like, hey, don't touch that snake. Oh, you already touched it. Unbelievable. All right. Good? So, here's what I want you to do. Make the left look like the right. Go. Okay, how many got it? All right, well, the first thing to look at is, well, can I combine anything here? And it really doesn't look like I can. When I start taking a look at this, I know I can change this thing. 1 minus cos squared theta, if you think back to your Pythagorean identity. Sine squared theta plus cos squared theta equals 1. Don't forget my thetas. Okay, well, that means 1 minus cos squared. So if I take this and move it over to this side and subtract it over there, I'm left with sine squared. This whole thing on top becomes sine squared theta. Okay? Secant squared is the reciprocal of cosine. So I could change that to 1 over cos squared theta. Okay? Which allows me then to take sine squared theta and divide it by 1 over cos squared theta, which is the same as multiplying by the reciprocal, which gives me cos squared theta on top, and subtract sine squared theta. Okay? So let's make sure everyone's clear what I just did there. Okay? So when I take sine squared theta, this is just what we kind of worked on the previous problem, and divide it and put it over 1 and divide that by 1 over cos squared theta, you got to just get in the habit of thinking, okay, I'm going to multiply by the reciprocal. So I'm just taking kind of this chunk of the equation right here. Okay, that, when I flip that, it becomes 1 times, or excuse me, cos squared theta over 1. So I get sine squared theta times cos squared theta right there. It would be nice if you're struggling with that, that's something where you want to remember or try to memorize that, look, anytime I'm dividing by a fraction, it's the same as multiplying by the reciprocal. Then I'm going to subtract out the sine squared theta, which we bring down there. And that's all equal to that. And I'm not just going to keep writing that, okay? All right. From there, when I look at this and this, it almost looks like a dead end except for they have two things, or they have something in common here. They have a sine squared theta. So I could take sine squared theta and factor it out. When I pull a sine squared theta out of this, I'm left with cos. And then minus 1. What's cos squared theta minus 1? Let's go back up to our Pythagorean identity from earlier. Thank you. Okay. When I subtract 1 over, and I have to subtract that over, this is negative sine squared theta. And sine squared theta times negative sine squared theta is, make sure you know you're multiplying and not subtracting.
What is that? It's not cubed, it's
To the 4th power.
negative sine 4 theta.
You've now verified.
Wait, what's that mean though? Not the verified part. What's the whole, how do you say the 4?
To the power.
Sine to the power of 4.
That's not nearly as much like cubic or like square.
Quartic. Okay.
Sine quartic.
All right. Number 10. Give it a go. I'll be walking around. If you had questions on 9, ask me, please.
I got to 1 plus
All right.
x over sine.
So cosecant x plus cotangent x. All right. Cosecant, same thing as 1 over sine. Cotangent, same thing as cosine over sine. Which is convenient that they have a common denominator because now we have 1 over cos x over sine x. I know, I thought it was funny too. Okay? Now,
Wait, whoa.
no, that would be if they're squared. That's a good question there.
Wait, can we just put theta in the place of x?
Could we? You could put theta in the place of x. That would be fine. Okay? Hey, stay with me, please. Walsh, almost 10th grade. Okay, so close. All right. Hey, really at this point you kind of look like you're at a dead end, but over here they have 1 minus cos x on the bottom. So I'm going to multiply by 1 minus cos x. So if I have 1 plus cos x over sine x, and I multiply it by 1 minus cos x over 1 minus cos x, that at least will give me the 1 minus cos x on the bottom. Okay, so at this point on bottom now I have sine x times 1 minus cos x, make sure you put parentheses. Then on the top I have 1 plus cos x times 1 minus cos x, which is the difference of 2 perfect squares right there. Does everyone see that? It's a plus b times a minus b. right? So that would be, when I'm multiplying those two things out, that gives me this squared minus that squared. Now when I do that, first, is everyone clear on that? Yeah or no? I mean, it's okay to say no. I just need to make sure we... Okay, Matt, question?
You put a theta on top when you have
Oh, thank you. Okay. Yeah, try to stay consistent with your variable. That's a good point. Okay? All right. What is 1 minus cos squared? 1 minus cos squared is sine squared. So this becomes sine squared. Sine squared x. Okay, so now what can I do with the sine and the sine? Cancel. So I'm left with sine x on top. That canceled one of those over 1 minus cos x. Hey, that's what I want.
verify.
Check it off, man. You're done. I'm going to check this one off too. There. Now I'm done with that. All right. All right. Questions?